This room is named after a guy called Joseph Engelberger, and most people have, in their 20s and 30s never heard of him, but he's actually just died, unfortunately. But he was, they say, he's the father of robotics or automation back in the 80s. He was back in the 80s when I was a young man or a younger man. That was one of the first robots I worked with, Unimate 2000, a hydraulic machine. It's pretty powerful, pretty variable when it got hot, and it leaked. But as you see, the labour content's gone down, the automation's gone up. Still mechanised, still sequential. That's probably an early 80s production facility. And there we move on to the BMW plant in for Mini. You see no people at all. Again, still sequential, probably still a lot more flexible, better use of materials and qualities, and in this case, electric robots. So less likely to go off into the sunset. So welcome to the future. So what are the customer requirements for the future automation? And this is true of almost every industry, whether it's the food industry, automotive industry, or whatever, or the bearing industry. They want quicker changeovers and more flexibility, smaller batches, mass customization, if you like. I want what I want, not what the other person's got. And that therefore drives down makes requirement more flexibility. Costs are obviously critical. You want costs down. Labour costs, we were talking about a minute ago, the minimum wage is going up £9 an hour. That's a real driver, so automation has to drive that cost down to get the labour content out of it. And it's got performance has got to go up. And the other thing as well, delivery. So, particularly the auto industry we work on, the future will be, you don't want to wait, you can't wait, in fact, it's just in time, just tomorrow morning, or just the next few hours. So the problem is with sourcing things in the China, India, and so on, is great. The product's not necessarily a bad product, but it's a long supply chain. So gradually people are coming back into Western Europe and making the components for vehicles within Western Europe, insourcing they're calling it. Because it's again to shut the supply chain down, make it shorter and make you react faster to that variation. And obviously quality with very high availability. Any equipment you're making in automation in the future has got to work 24/7, 5.5 days to 7 days a week, with a lot of uptime and whatever, no failure. And the other thing, it's got a buzzword. Everything's got a buzzword in industry, hasn't it? So service support whole life from start to finish, not just supplying a black box you're going to put in and say, oh, forget it. They call it servitization. So it's providing complete support service from start to finish, including at the end. When the machine is finished, it's finally it's dead, then you might have to take it back as a supplier of automation to recycle it, take it apart. And also, with the variable, we're always talking about now with imported staff, if you like, coming to work in the UK, the English is not their first language. Their skill set may not be what you think it is. So therefore, the automation in the future needs to be able to interface with that operator and get the output from the system quicker, faster, and easier with a variable staff. They might change next week because they're contracted staff, and that person's not there next week than he was this week. So ease of use is a real key thing. So how are we going to do that? There's lots of buzzwords, Internet of Things. Basically, it's adding more intelligence to simple components. And in the automation field, every sensor will be connected together, if you like, every actuator will be connected together, and so on like that. So you gradually drive the intelligence, some of the intelligence, distributed intelligence, I suppose, down to a real low level. So it allows components to talk to each other. So they can find out what the next component's doing in the chain. And now things like putting it into the cloud, which is, okay, it's got its own problems of putting stuff into the cloud. It's one of those fantastic solutions that has, if it works, it's great. If it doesn't work, then everyone's stopped because the cloud's gone away, if you like. But Bluetooth, for example, are now issuing low power Bluetooth Smart, for example, and other things like that, FISB, are where you can actually send data into the cloud for components and so on to communicate into the cloud and back down to the system and so on. And it uses it for performance monitoring, data collection, and for maintenance and service. Then I think there's also going to be a growth. It sounds a bit futuristic. This is Asimov. This Honda, I think, named him after Isaac Asimov and taken the V off the end. But for certain things where you've got a human-sized application, it's not very heavy, but fairly really be dexterous over the next few years. We're going to see a definite growth in that sort of equipment. It may not be a total humanoid, it may be half a humanoid, if you like, on a trolley or whatever, but it's got the capabilities of a human. And the key thing I think in that will be much better vision. We've seen cameras have got 8 to 24 megapixels perhaps in vision. We're talking 576 megapixels for a human eye, and we take it for granted. It's a single lens, but it's got tremendous analysis power behind it, and that's where you need to get to with a vision system on a robot or a humanoid, if you like, from name, and particularly binocular vision, so it's looking at that, so you can triangulate and work out where things are. When you've got that, when it's cheap enough, then you've got a real useful tool. The other side of that, not just the vision, but also soft robotics, again, a little buzzword if you like, able to handle things with a variable grip. It's already been picking up a spanner with a tight grip. You can squeeze a spanner as much as you like and nothing happens. Pick up an orange, squeeze it too hard, and you've got orange everywhere. So you need to be able to do that with feedback and sensitivity, particularly when it's putting stuff together. You need to know that. So that's the other thing. And I'm throwing in there smell. You know, we discount smell, but animals have got a tremendous sense of smells, and they use it for the smelling dogs who've got diabetes or whatever. Well, so gradually, I've used sensors in the past, and we will definitely use them in the future, where I'm smelling the decay of fruit. So when the fruit sets off, it's really fresh, doesn't have a smell. As it decays, the smell comes off of it. So therefore, we transported the lorry a different way to get it to a juicing factory as opposed to the supermarket to put it on the shelf. So if we take that and take it further into automation, in the future, could you have a sensor that's really sensitive enough to say, I think this machine's beginning to smell, or whatever, and you can smell it before the human can smell it and say, shouldn't be getting hot, should it? That's a crude example, that sort of thing. And the other thing, trying to make the thing more modular, a bit like Lego if you like, where you can take it apart, put it back together, reconfigure it. It's a bit like robotics, but perhaps more hard automation, reusability, trying to reduce, again, it's the same thing, trying to reduce the costs associated with the project but maintain performance. The other challenge will be, and it's going to be a bigger challenge with the robots, is the operation and automation working in the same space. You see that's an ABB, twin-armed robot, and an operator. There's no visible guard between the two. That's a real challenge to make that safe. In the present state of the art, with a hard robot like that, is a I don't have a solution, I think. Certain types of robot are a bit softer, if you like, can cope with it, or slower robots. But that's going to be the challenge we need to get to, where the operator, the human operator, is bringing certain skills, and the machine, an arm or whatever, is doing certain skills, and you're in an environment dynamically. Whereas two humans working together, they know intuitively, if you put your arm down and you put my arm down, we don't clash, do we? We talked about it a minute ago. The other thing to make it easier as we go forward will be not only voice command. You've got voice command in your car, which is pretty good, but I'm not sure we really want to be commanding a high power machine tool by shouting at it on a Monday morning when there's a lot of noise. But we do as humans, we shout at each other and we know what we're doing. So that will improve in the future. And also the machine looking at the operator and saying, okay, I can see your face and I can see what you're doing, you're the right person, I can see from your expression you've got it right or whatever. So a two-way connection between the machine as well going the other way. And the thing we haven't talked about much, but the major thing between what we said on the history, if you like, and the future is the ability to control things much better. And the level of control you can put into it, like putting stuff into the cloud. It's all really degrees of control. The mechanics have been around. The Victorians were really good mechanical engineers, but they just didn't have that sophistication of control. Now we do have that, and it's going to go faster and faster and smaller. It's like the computer age, where it doubles in power and halves the price every 18 months. So the same thing with sensors and the connection to the internet. The amount of capability we can put into systems that allow us to do stuff grows all the time, and it will grow. So using artificial intelligence, supposedly the humanoid thinking process, if you like, can predict problems and try and sort them before they start to happen. So this might happen, we're talking about something heating up or whatever, suggesting solutions and improvements. And the next stage, well, it can come up with alternative routes to get the same solution. Why are you going down that way? I want to go that way to the solution. Taking little bits out and recovering, the recovery thing. But then, does it then, I think it will do, will the machines evolve to make themselves? It's the 1984 scenario of the future with all machines. I don't think it's going to go quite that far, but you can see the machines evolving to come up with a better solution than you've made in the first place, because you've given that ability to think about it and think, well, this is not the best way of doing it. I can do a better way. So what could possibly go wrong? Wrong, I mean. A shortage of skilled labour. That is one thing. Western Europe, we have an ageing population. So even though we're trying to automate, take labour out, at some stage you need quality, skilled engineers to put the machine together in the first place and come up with the concepts. And if you don't have those, that's a real struggle. So you don't necessarily need for operation, but you still need for support. So somewhere, and that's the end user typically is de-skilling his engineering base because of cost. So it's coming back on the automation system supplier in the future to provide that capability, and that could be a real bottleneck. We shouldn't forget disruptive economics. The Chinese market's gone down at the moment. India's gone down a little bit. We don't know we're going to be in or out of the EU. Those sort of disruptive destabilizations are a real challenge in automation. Do you actually invest in anything at all? Do you just keep using cheapish people? until we get out of it. So that will affect on the thing, on the future. Legal structures, as we talked about a minute ago, how do you make it safe with more and more automation that's supposedly thinking as you're thinking, but is it? And the big things there, environmental challenges, the whole life costs. When you finish the machine, can you take it apart? Can you make it to take it apart? That's going to be a challenge as well. Okay, if you're going to use lots of humanoids, if you like, then there's a programmable, but eventually the humanoid's going to wear it. You want to take it apart, you put your leg on it, whatever. But you need to think of that when you're designing it. We will have to think of that. And the just availability of material, you know, with Tesla, with his new electric car, is going to have most of the world's supply of lithium. It needs to be making more batteries from lithium in a few years' time than we've made ever per year. So therefore, the raw materials is going to be a problem, and we can't discount that. There's a lot of electronics and computers and automation use an awful lot of very specialist materials, not necessarily lithium, but lithium polymer batteries, for example, and so on, and things like tin, and also power. That's a challenge in the future. We can't just assume we've got unlimited supplies of power. Where does it come from? Can we be more efficient with our power? And the final thing is, well, we've got ever shorter customer attention. And the customer wants, I want it in my colour, I want to change the colour. So why do Apple keep bringing a phone every 6 months? It's not because they love us, it's they want to make the customers demanding to have a different phone. Well, why do car companies bring a half-life uplift 18 months or a year after the first one's come out? There's a perfectly adequate vehicle, and they're probably selling them, but they've upgraded it, changed something. Because the customer's demanding that little thing to keep them stimulated. You know, JLR, for example, have loads of different wheels on the car as well. How many different wheels do we actually need, if you like? But that's the customer-driven thing, and we have to meet that. Okay, briefly, finally, let's look at another view of the future, slightly larger-hearted possibly, but it could happen. We could have drones delivering, monitoring operations, carrying out repairs, changes with a live system. So flying over the top of the system, checking the system. If like a big warehouse, why not? You know, drones are more and more accurate. Do that. You deliver spare parts. You can even deliver your staff. What we're not talking about is much is 3D printing. We saw some machines on the shop floor with 3D printed, additive manufacture. Why can't machines in the future, when it starts to wear out, it says, well, if it's wearing out, it just talks to another little machine next to it, makes that part, fits it on, and keeps going. So it self-repairs based on the thing. So, you know, why not? Exactly, they're starting to do. You can get 3D printed parts on the shop floor of plastic, but now we're starting to get them out of composite metals and so on. So there's no reason why, with the right program, one of those machines, the machine can repair itself without any intervention from the human operator. So, the final slide, I'm pleased to know, whatever the future of automation, and that actually is a softish robot, if you like. It's called Baxter, and it's supposed to work in an environment where it can be with a human and sort of not bash into it, but it's all got a fairly loose joints, and suppose you can move it from place to place and switch it on and reprogram it. It can be making your pies one day, it can be making your bearings the next day. I fail to see that actually it's going to work quite as good as that. I thought it's a salesman's snake sort of sales, but you know, that's the way it could well go. But the concluding thing is, I think the keys are going to be flexibility and integration with control, and control is probably the key of future automation. So that's my talk, and that's how we foster automation. So thanks for sitting in quietly and not booing me. If there's anybody got any questions, we can take it up, or we can have some lunch upstairs, I think, in a minute.